In this lecture, we will study about the concrete slab design. So let's start. Start from the beginning. Select a SI system, and this other two is used for steel structure. I use the concrete as ACI C1318-14 for concrete designing. Select the edit grid line because we use variable dimension from the drawing. So x direction is 5.20, 6.30, and 2.90. 2.90. So now check again, it is 2.90. Now let's move to y direction. This is a y direction 5.20, 4.40, and 7. The grid lines also showing the display shows the spans. So okay, select the story 3, and typical story height is 4.20 and bottom story height is 1.50. It is the height from the foundation to up to tie beam top level. Define the material properties. Add new material. Select the country you want, but we select a concrete of the United States of America. Concrete 4000 psi. Already we select 5000 psi. Check the MPa 34.47 MPa. It means 35 MPa. Concrete has been designed. Add new material as a rebar. So a 60 grade concrete is we have already, but we now select a 75 grade concrete. If we need it, we will use according to the reference book or reference codes book. Okay, now define section property of the materials. Select a rectangular, delete this one, add new property, rectangular as a C1. The size of the C1 is already given here. C1 is 200 by 400. 400 is depth and 200 is width of the steel bar. 75 and show rebar. Rebar is the use of 60 grade steel and concrete cover is 25 mm, and the steel here using is 3 and 3, and say die up bar using will be 16 mm and 8 mm will be stirrups shear bars. Add the new property as a C2. Add the name as C2. The size of the C2 is also here 200 by 500, 200 by 500. Now select the 16 mm die up bar for this column and 8 or 10 mm per you can use here, 8 mm or 10 mm per shear stirrups. Okay, modify and show has been completed. Now you can also modify it after. If you select OK, after you can modify and show property, you can edit the property again. So now add the C3 as like the thickness of the C3 is 200 by 600, and 600 is depth and 200 is width. And modify and show rebar. So the rebar using 60 grade steel, 25 mm is thickness in steel using here. The number of steel is 9, and the 16 mm die up bar using here, and shear rebar is 8 mm as a stirrups by name of stirrups. You can also reduce the shear through use of multiple types of stirrups. It depend on the load and type of the building. So now select the B1 has a size of 800 by 200, so the 800 is depth and 200 is width. The width of the beam and the column we kept as like the width of block that a proper finish has been received. So therefore we increase the depth of the column and the beam. So in beam, now select the B2. The size of B2 is 200 by 600. Now we not completed the B2, so how you can modify and show. If you when you click on modify and show, the following window will be appear. So change this and also modify the rebar. Here select the M3 design only beam. 25 mm is thickness for this beam, and this is for ductile reinforcement, ductile beam. So now this is the detail of the beam B2, 400 psi, and that is anytime you can change it and you can make a modification in the property of beam and column as well. Now HB1 is 200 by 200. The HB1 head and beam mean the beam we provided on long span as like the thickness of the slab, same like the thickness of slab. For plate slab mostly we can reduce the span by providing this head and beams. Go to slabs. Now we select slab properties, so go to slab, modify and show. You can also but add new if you want to add new, so add new one. Concrete thickness 4000 psi, and the model type is shield thin, and 200 mm is thickness of this slab has been selected. Now we will move to assign the columns to select the similar stories or all stories, because the column is from base to the top of the building. So change the property of the column. When you select a C1 or C2, you check in the drawing that what is the orientation and position of the column. So now check in the it is longitudinal towards x direction, these two grid lines. So drag the mouse and click on and drag the mouse, the column will be automatically drawn. It is the easy way if the column orientation and size same. So now this is also C3 columns. If the line is straight, you can also click and drag the mouse. So now here you can also assign the columns one by one. As this is C3, so you can drag them to save the time. Now the one column here, the orientation of the column is changed. So you will learn about that how we can change the orientation from 0 to 90 degree, from 90 to 180 degree, and minus 90 degree and minus 180 degree. So now we see that the orientation and from x direction towards y direction, so it is 90 degree from x to y direction. So we will provide 90 degree up angle. The size of the column is 200 by 500. In here we selected 90 degree So you will check that the column orientation has been changed from the position and orientation of the other columns. Now select the beam property of the beam. The property of beam is B1 selected, 200 by 800. 800 is depth of the beam and 200 is width of the beam. So here is 800 at the blue line. The size of the beam is 800 by 200. So as like a column, you also can click and drag the mouse to draw the beam also if your beam size same. So here is some beams as size is different from others, so therefore we select this by one also. This is the long span. The beam size must be keep high with respect to the short span. So the other span is short, we will provide as B2. You also can add in property a lot of beams and different of beam sizes, because when your project fail, in another video we will inshallah we also make video regarding this, that how to pass the fail beam columns or slabs. So now select the B2 for this short spans and assign them one by one to the model. The beam has been assigned from the tie beam to the top of the roof. You can also drag the beam if you need. You can also drag them and also can delete them also, such as we draw the beam. Now we want to delete this beam. So how you will delete? Select the beam. This is the when you right click the beam, you will go to the details. So this is go to the beam, edit and delete, so the beam will be deleted. So now assign the slab to this model. Select in one story and go to the first level. Now we are on tie beam level, so click this arrow and go to the 5.7 first floor level. Here we assign floor here. So drag the click the mouse and drag them, so the slab or floor has been assigned to the model. So now there is a lot of ways, but we select all the floor and go to edit menu and click on the replicate story, and the two, this is to story 2, because the one story is tie beam. So select the story 3, this is the last one story. So and okay, so now you will the beam or the slab is also assigned to the top of the model, the last slab of the third story. It is basically ground floor and first floor, but we can here put that we assign 3 story, as the bottom story height is 1.5 meter. It is tie up to tie beam level, as we already said. Now we want to select this beam, select a similar stories bottom and click and go to delete and delete this one, because here we will design shear wall in next video. So now we move to load pattern, and here we add a load, super dead load and live load is already here. So we will add super dead load, and the type of the load is super dead. You can also add the number of the sit weight of the load 1 and OK. So now select all the object, assign shell, uniform load. Basically in Slab we have the combination of 3 loads: live load, dead load and super dead load. Now we add live load or super dead load as 1.20 kilonewton per meter square. 1.20 kilonewton per meter square. Okay. And now again select all the objects. You can also select from the left bottom. Select all the objects. Uniform live load will be 2 kilonewton per meter square with reference of ASC 710.25, and you can add it up to 2 kilonewton per meter square. It depends on the stories also. Now we go to load cases, add new load cases. A click on use P delta settings. Analysis model will be default. Add new one, load pattern 1. Okay. Now define the P delta as we selected P delta in load cases. So here we add the value of P delta here. Live load 0.25% of overall loads. And add dead load or super dead load 1.2 or 1. Then the dead load is already mentioned, it is 1. We added it in load pattern as a 1 for the slab. Basically this all the dimension. You will use the reference code for this book, international code book. So now go to check the minimum cover for the slabs, and we use ACI 314 318-14. Here you can modify all the dimension if you want, if needed. Now we add the stirrups. So go to edit and add the stirrups. Here is the select this one and OK. X A direction, it is the stirrups X and A direction. So the stirrup has been created. So now change the direction of the stirrups to layer B as like A, Y and B and click OK. Select R2, it is mentioned by Etab. If you select R2 calculation, so the stirrups will be auto calculated. Now select all the object type, select the layer A and B. We want to replicate this layer to the story 3. The layer has been selected, stirrups has been selected, layer A, B and B. Now we go to edit menu from the main menu and click on the replicate. Select the story 3 and OK. Now the layers has been replicated to story 3. So the stirrups has been replicated to story 3. Now let's run the analysis. Now don't run the model because we don't need model. We need these 3 loads: dead load, live load and super dead load. Click on run the analysis. Now don't run the analysis. Here you have to select for model, run the analysis, save the model. It is very important to save the model to make changes. Model has been. Now we have to run the analysis. Select the story 3 and here you have to select the story 3 for the run. Check the model, check the slab one by one. Now the checking is completed. Now we will discuss detailedly the right click on the rubber. ACI 318-14 will, the detail report will be appear the span 6.2 meter. It is the span, and this one is the moment and negative moment and positive moments of the spans. So here is the bending moment, and the shear, last one is the shear diagram of the building. The structure engineer will study this diagram. Now select the display info. It is the layers of the B, the A and B layers for the slab, and top and bottom bar we will check one by one it. So now first of all we will select a layer A as already checked, and show the top rebars selected, show the top rebar, apply, and see the top rebars. The top rebar of the layer B is showing here. The, the blue line indicate the top rebars and bottom rebars of the layer A and B. So we already selected layer A, show the top rebars, and this is the top rebar of the layer A. Now select the layer B and show the top rebars of the layer B. We will discuss it one by one for your good understanding. So this is the layer B and showing the top rebars to reduce the shear flow. So here the span is less than the other span, so the top rebar is extended, and the second one and the middle span in the column, every column the top rebar has been extended to the columns, another column, but in middle here is not extended. It is extended to 1.5 meter both the side of the beam. Now select layer A and show the bottom rebars. Select the bottom. OK. Now the blue line will show you the bottom rebar of the layer A. So the blue line shows the bottom rebars. The bottom rebar is continuously extended the bars from one to other end, and the top is the curve starting and the line has been created. I will discuss you with detail by the signs from here to left side. The first, this line is top, this line is top rebar, and here is, see, from here to left side top rebar, and from here it is top rebars. Here is seeing that if you drag the mouse, you see the top rebar is showing as 0 in the middle span. Here is also the top rebar showing is 0. So from this point to this, both the points in left and right side of these arrows showing that the top rebar is needed. It shows top rebars. in the middle span is top rebar is 0. Between the two arrows, the top rebar is 0. Here is the top rebar and the middle span. The top rebar is 0, as you also seen before. We discussed about the top rebar. So now we layer B show to top rebars. Click OK. Now you will see the top rebar. Here you can see that the top rebars has been as like before we discussed, without showing the rebars, that minimum 1.1 to 1.1 meter or 2 meter. It is basically showing in the detailed report, and next video we will issuing the detailed report, that how we make a detailed report. The CSI system from the 2018 and 19 Etabs separately designed a CSI detailing software. You can export the report a model from the Etab to the seaside detailing software. It calculates detailed report. So now here you can see that the top rebar and the middle span is 0, and top rebar in this both this side is needed. It must be provided to minimize the shear force here. And this is the column. He also provided the top rebars are for all the columns, and here in mid span here is no top rebars provided from